to welcome you to today's webinar on becoming an engineer. This webinar will explore issues around STEM identity. Identity is about how we see ourselves and how we fit into the world. And our goal, as we're talking about becoming an engineer, is to help young people see themselves as someone who does STEM in the world. We believe this opens up career opportunities for them. And I'm going to introduce you to resources that you can use today to help the youth in your program see themselves as an engineer, and also help the staff who work with them to support identity development and helping youth see themselves as someone who thinks critically, solves problems, and helps people, and talk about how this identity is an advantage for young people in everyday life, as well as in the opening up for them the possibility of having a STEM career. We're going to start by brainstorming a little bit about how we see engineers, what we think of as someone who might be an engineer. In the chat box, I'd like you to share some ideas about things that engineers do on a daily basis. We'll be using the main chat box today for our brainstorming. So we came up with a lot of things that engineers do. Engineers are critical thinkers. They solve problems. They construct things like bridges. They plan. A lot of times engineers are just the ones who create ideas and plans, and other people put those plans into action. They work together. They improve things, repair things. They do a lot of math. I like that. Measure, add. We've got they solve problems, communicate. What I want you to think about as we think about what it is that engineers do is to realize that some of these things are pretty unusual. Not all of us build bridges every day, but all of us do communicate. We use math to measure, to add, to get the sense of the world around us. We solve problems on a daily basis. Parenting is all about solving problems. Teaching is all about solving problems. So these are all things that engineers do, but some of them are things that the rest of us do as well. Now, the next topic we're going to talk about is next generation science standards. And I know for some people that's something you're familiar with. For others, it may be something new. So as you think about next generation science standards, if that's something you're familiar with, what other ideas does that give you for things that scientists do? Are there things in the standards that aren't on our list yet? Using mathematics and computational thinking to measure, to add, to evaluate things. That's one of the next generation science standards, and it's also one of the items that's on our list already. Let's look at what the science and engineering practices. Hypothesis testing, good. Experimentation. That's definitely one of the practices that we talk about. These are the practices of science and engineering, as you can see in the next generation science standards. And I'll share a link with you in the chat box and add it to our list below in a little bit, of where you can go to find more information about those science standards. But what I want to point out to you is these are the practices of science and engineering that the young people in our after-school programs and in our schools should be using. And we want them to feel comfortable with these practices and know how to use them in real and authentic ways. I like this graphic from the blog down below, There's No Scientific Method, because it reminds us that scientists and engineers don't necessarily follow linear steps through these different practices. There isn't a single method that they always follow to solve problems. The goal is to solve problems, to find answers, but they use these practices in a lot of different ways. They may have standard protocols, and usually a new project will start with brainstorming or generating ideas, but then things can go in a lot of different directions, and they can come back and revise a hypothesis or decide to construct a new model of their idea along the way. The goal is that we come to a conclusion or a solution, but oftentimes it's not a final answer, because the more we learn about something, the more we research, the more we realize that there's more questions that we have, more places that we could jump off and start the process again. So the idea to take away from here is that we already knew a lot of these things, like planning and carrying out investigations, communicating information, using mathematics and computational thinking, designing solutions. These are all things that came to mind just as we were brainstorming about what it is that engineers do on a daily basis. But they're practices that are important not just to scientists and engineers, but are important to young people too. So look at this list of science practices and think about, are there any of these practices that the young people in your program have used in the last week? What practices on this list have you used with youth? Are the youth in your program already doing science and engineering, or is this something new that you're adding to the programming that you offer? Share your ideas in the chat box and let me know if this is something you're already doing, or if it's something new, or if there's any of these practices that you're already having youth do. In the chat box, I'm sharing the story. I was watching a group of adults who were doing the Nutty Investigator activity, and they're using tin cans filled with weights to crack nuts. And it was a real impressive testing to failure sort of moment, which is something that engineers often do. They were trying to break open a macadamia nut, and they had gotten enough force on their can that they actually broke the tin can over the shell of the nut, but the nut didn't break open. So in that example, they were planning and carrying out investigations. They were using mathematics and computational thinking to decide how much weight they needed and keep track of the weight they were using to crack the different nuts. And then they were engaging in argument from evidence to come up with some explanations of which nuts were the most difficult to open. And surprisingly, not everybody got the same results from their testing, but they all found that macadamia nuts are very difficult to open. It looks like a lot of people may not be using these practices right now with youth. Jeff shared some ideas from his program that they use these practices regularly as they talk about the scientific process. But in a lot of programs, this sort of approach, thinking about the practices of science and engineering, may be new to the youth in your program. So I will add the web link for you to find out more about the practices. Why it is important to think about engineering in terms of identity. So we started off thinking about what it is that engineers do, these practices that they engage in their work, and then thinking about how these might connect to what we're doing in our programs with youth. The goal of having youth engage in these practices is that they develop skill and expertise with the practices of engineering so that they are equipped to use them in their day-to-day life. Whether they decide to pursue a STEM career, and that could be a career like construction management that might take 2 years of training, or even an apprenticeship like plumbing that could help prepare them for that STEM career, or it may be an engineering career where they're going to spend 4 or 6 or more years at a university to get trained. But whether they're entering a technical career or a research-based career, we want to value our students and the expertise that they bring to problem solving. And this is an issue that gives us opportunities to consider equity and how we encourage youth to work with ideas, materials, and tools and processes in different ways and value the expertise that they bring from the skills that they're learning at home or in their environment before they come to the program. We also, in order to help youth develop an identity, need to be open to deep engagement with student-driven ideas, to set up programs in a way that allows for collaboration among learners and for learners to collaborate with experts. That may be yourself as the facilitator of the activity, or there may be community experts that you bring in, engineers, college students, high school students, that can come in and share some expertise with the youth in your program. It's also important when you're trying to help youth develop an identity as an engineer to give them multiple cycles of design and discovery. That problem solving takes time, and we need to encourage that in after-school programs. All of these research connections and more information about research on helping students become engineers is available in the overview of learning from making and tinkering, and that is one of the PDFs that you can download in the resources to download pod. I want to encourage you to think about how do we support youth in a way that is equitable, that recognizes the expertise of everyone, and gives them access to these ideas and these strategies that engineers use. Because an engineer can come from any of the youth in our program. There's not a particular ethnic group or economic group that leads to being good engineers. All of our students have the opportunity to pursue a career in this way or to use these skills in their everyday life. So we want to keep those things in mind as we're helping support youth in seeing themselves as someone who does engineering. In order to make this more real for you, I want to give you an opportunity to see a video from the Click to Science site. We're going to watch some after-school staff engaging youth in thinking about how engineering connects to their own experiences. The activity that they're doing in the video is designing and building a roller coaster. So look at what strategies the staff members use to help youth connect to their own experiences with roller coasters or with force and momentum. Before we watch the video, I'd like you to share some ideas in the chat box. Why is it important to help youth make connections to their own experiences when you're doing an activity like this? What benefit do you think youth get out of making these sort of connections? So, when we think of engineering as problem solving, then it's easier, I think, to recognize that this is something that everyone does. Everyone engages in solving problems. And so we want youth to see that the practices of an engineer are practices they can use in their everyday life, that having strategies for solving problems are accessible to them. It makes engineering less intimidating, and it values the contribution that individuals bring to our program. They already have some skills and expertise in solving problems, and they're using those in different ways. So we want to help them connect what we're doing in the after school, the STEM we're doing in after school, to their experiences in the classroom, as well as their experiences in everyday life. So in the video, watch for the facilitator using the youth's background knowledge to prepare them for the activity. and see how she gets them excited and engaged in the activity. When we come back, we're going to have another discussion in the chat box about what strategies she's using to get youth engaged and how she's connecting to their prior knowledge.
Loops, yep.
Because I get to go upside down.
Yep.
You get to get scared.
It scares you. Yeah, there's something about it, right? This is the Hydra at Dorney Park.
Youth love roller coasters. What better way to get them excited about an engineering challenge than having them work in teams to design a roller coaster? Youth are given the materials, a demonstration of one way it could look, and a challenge of only so much money or tape, and let go to create a one-loop roller coaster. Watch how frontline staff model interest and excitement to get youth talking about their design.
This is a track. This is a stand so that you can connect your track to it to get some height off the table. We have these things here called clamps. You have a pencil in case you need to do any documentation, and you have 2 cups with how many marbles?
3. Thank you. I lost it. We need it closer together, probably.
You think it has too much force? What made you think that?
I don't know, just because like it's heavier, because it's bigger, so I think it's just like hit it with more force.
Good job. You got both marbles to work. Fantastic. All right, you're getting closer now. Hey guys, it just needs fine tuning, and then you're good. Okay?
Oh, there we got one.
Did you get one? All right, good.
Please share some ideas in the chat box. What did you see the staff doing to get youth engaged, and did it work? How would you do it differently? One of the things I really liked is that she had this virtual roller coaster experience. It was kind of quick in the video, but she was showing a video, looks like a GoPro video of a roller coaster, and the kids were pretending they were on the roller coaster, putting their hands up and enjoying the ride. I think that's really important because depending on where your program takes place, it may not be the case that all the youth in your program have experienced a roller coaster. We want to let them see what that looks like. And then if they haven't experienced a roller coaster, help them connect to other experiences where they have felt force and momentum, that they've experienced the pull of gravity as they were jumping off a swing or some other experience, racing Hot Wheels cars. And then she gave them some broad instructions about how to do the activity, examples of what the supplies were, and how they could be used. But the challenge itself was very open-ended. So if you were leading the activity, how might you do this differently? What are some things that you might change to help keep everyone engaged and to build on their experiences and help them see themselves as an engineer? The language that we use in the classroom is really important in terms of how youth see themselves and how they experience an activity. We might share leadership responsibilities, have some roles for youth, or opportunities for them to have control and decision-making in an activity. That's a really good way to develop identity. Just using language like calling the youth engineers, calling it a design activity, can help them see it. Maybe finding a video of an engineer who designs roller coasters talking about their work so they can see how that happens in real practice. Are there any other ideas that you might use with this particular activity of designing a roller coaster to really focus on this idea of helping youth become an engineer? I like the idea of using leadership and opportunities for youth to be making decisions about how they're doing things. That's an important part of developing identity. We're going to be talking about design challenges like this one throughout the webinar today. And so I have some tips for you about design challenges. And I want you to think about this first part of the webinar here as strategies that you could use with your staff to help prepare them for leading this type of activity. So showing a video like the one we just watched and discussing how the staff in the video prepare students for the activity and what you could do differently, how you might adapt the activity for this particular goal of helping you see themselves as engineers. This is something you can do in a short staff development activity to help your staff build the skills to help youth become engineers. And a little bit later, we're going to share some programming ideas, too, that you can add to your program itself to help youth see themselves as engineers. Another thing you can do with your staff is share some tips or strategies with them. And these are my 5 tips for when you're doing design challenges with youth to really help them be successful and see themselves as engineers, as problem solvers. First, staff and youth need to think about challenges as a challenge, not a competition. These are opportunities to be creative in solving problems, but we don't want to award a first place or a best solution to anyone in the group. Instead, we really want to emphasize the idea that there are lots of possible solutions and have teams brainstorm a lot of different ideas before they get started so that they understand that there's not one good solution or one answer to a challenge. There are many right answers. So we want to keep this very open and encourage divergent thinking as we're going through a challenge like the roller coaster challenge, or another one we're going to see a little bit later in the webinar. We also want staff to have strategies for when things aren't working, when they're doing an activity like this. So when things are not going right, one of the strategies we have when they're starting to get a sense of frustration is to encourage youth to try again. And one way to do that is something I call an idea walk. An idea walk is where the team just stops and moves away from what they're doing and walks around the room to see what other people are doing to get more ideas. And it's a strategy to use when youth are getting frustrated. Sorry, it's hard for me to talk and type at the same time. So an idea walk, the group gets up, moves away from what they're doing, walks around the room, looks at what other people are doing, trying to stimulate some new ideas or different approaches. Again, you're reinforcing the idea that it's not a competition. There are many good solutions out there to a challenge, and they can learn from one another and from other teams. So one strategy when they're getting frustrated and you need to get them refreshed and restarted is to do an idea walk and physically moving around the room and getting away from where they've been focused and seeing things from a different perspective is often very helpful. Another way to get teams out of a rut and encourage divergent thinking is to use some powerful questions. So powerful questions are things that are going to help them think about what they're doing from a different point of view. And let me share some different questions with you in the chat box. So the idea here is that you're going to really try to get them to think about things from a different perspective. What do you think happened? That's a good question if things aren't going the way they want. What led to their failure? What are the step-by-step process? I use this a lot with robotics because I need them to describe for me exactly what the robot is doing so they can think through the steps of the process. But in any design, a Rube Goldberg machine or a roller coaster like this, having them describe what happened is very useful because it encourages them to think and analyze in a different way. And then you can encourage divergent thinking with questions like, what would happen if you raised it up higher, if the starting point was down lower, to if the marble is bigger? Why would that happen? Just, again, start getting them to think about things from a different perspective. And then rather than trying to solve problems for them, really encourage them to think about their solutions. What's another strategy you could try? What's another way you could go about solving this problem? To use those questions to get them out of the rut and thinking about it as from a different point of view. Does anybody else have tips that they have found to be very helpful when they're working with small groups around? I had some connection difficulties and lost my connection for a moment. So what other strategies? Breaking it up. I like that idea. Especially when people are getting tired and you just need to move away from it and come back to a difficult problem. Any other strategies you found to be useful? So let's review. We've got our 5 tips here on design challenges. We also talked about thinking very carefully about the instructions you give to encourage lots of different ideas. Keep your instructions broad. Give opportunities for youth to move, to get away from a problem when they're getting frustrated. Use your language to encourage youth to think of themselves as engineers, to remember that this is about solving problems, they're designing solutions. Get those words in there, engineering, solution, problem solving, so they know explicitly that's the skills and the strategies that they're using. All right, so I want to wrap up this first part of the webinar, reminding you that these are resources that are available for you to use from Click to Science to help your staff build their skills. So we used the meeting professional development guide called Make It Relevant to shape our discussion today. And you can download that in the resources to download pod, or you can go to Click to Science website to find it yourself. And we used the learning module, presenting a challenge, and there's a direct link to that in the web links pod at the bottom of the page, so you can see that video. One of the nice things you can do with the Click to Science videos is you can download them if you need to ahead of time if you're not sure about your internet connection. I did that for the webinar today just so I could be sure that as much as possible we were going to avoid technical difficulties. You can also download the activity itself, Design a Roller Coaster. So my recommendation here is that you bring these resources together and you get together with your staff. You show them this video and you have a discussion about what it means to help youth make connections to what they're doing and how this helps them see themselves as an engineer. And then you can give them the Design a Roller Coaster activity with very inexpensive supplies and have them practice this skill. The youth in your program will have fun with the activity, and your staff can build their skills in presenting an engineering challenge and helping you see themselves as engineers. So that's one way that you can use these resources from Click to Science. Now, the next thing we're going to talk about is more on a programming level, not a staff development level. And this is the idea of starting an Invention Club as part of what you do in your after-school program. Inventors are creative people who identify a need and create an original solution. This is really important because it's a little bit more accessible idea for some people than engineers. Inventors come from all over the world. I was just listening to a story on the radio about a 10-year-old boy who builds kites. He learned to start building kites from Myanmar when he lived in Myanmar. He's in a refugee camp now, but he's very good at using the resources that are available to him in the camp to invent lots of different kites that fly and are beautiful and fun for the other children in the camp. So inventors come from lots of different ages, different levels of education, different backgrounds, different socioeconomic status, and they create original solutions. So for many people, this word inventor may be less intimidating than engineer. But similar to engineers, inventors see different ways of solving problems. And inventions can be things, strategies, or ideas. Successful inventions are things that make something better. They make it faster, stronger, cheaper, or safer. Of course, not all inventions are successful, but any new solution to a problem is an invention. So one thing you can do with your program is start an Invention Club. An Invention Club will help youth learn how to solve problems and be creative. They will see how they can improve the world around them at home, at school, in their community, or in the world. One of the things that we want to encourage when you're thinking about an Invention Club is how to enjoy this process of being creative along with the youth in your program. Invention requires time for thinking and time for doing. So there's a resource in the WebLinks pod called Invent It, Build It, and it's a great resource for thinking about how to create an Invention Club for your program. The point of having an Invention Club is to have fun and be creative. Don't worry if your club doesn't come up with any life-changing inventions in your first semester, but be ready if your team does come up with a great solution to encourage them and help them think about how they can make that solution work. So this is a little bit about what an Invention Club can do and what the youth in your program would do in an Invention Club. These resources we're sharing are from Design Squad. And here I'm going to show you their tips for starting your own Invention Club. They recommend that you start out, before you're even ready to start, advertising your club, letting the youth know that it's coming, letting parents know that it's coming. Decide how many you can support in your first Invention Club and keep it small. Their recommendation is 8 to 12 youth. In an Invention Club, if you've got more people who are interested, you can start a wait list for the next group, or think about whether you can support more than one club. But each group that meets, you want to keep it small, that group of no more than 12. Plan your space that you're going to use, whether you're going to meet daily, once a week, twice a week, however it fits best into your program. Think about local inventors, engineers, problem solvers that you could invite to visit your club. They could be people who come and invent along with the students or share with the youth in your program what it is that they're inventing, how they're solving problems in their local community. And then also use online resources to engage youth and to decorate your space to make it fun and inviting. And at the bottom of the page, I shared some ideas. Women in NASA is a great place to find resources. Sci Girls or Design Squad are all great online sources that you can use to find ideas that will support your Invention Club. The design process that we've got pictured here on the different ideas, designing a solution, then building it, testing it, redesigning it if it doesn't work the way you think, and when you've got a solution you're happy with, think about how to share that solution. So this is the process that engineers use. It's also the process that you could use in your design, in your Invention Club. Are there any questions or concerns? A sense of what it might happen if you decided to go with this strategy of starting an Invention Club in your program? So this is one of the activities out of the Invent It, Build It resource that you can find in the web links pile. It's called Convenient Carrier, and the challenge here is the youth are going to invent something that could help a person who's using crutches or a wheelchair to get around. When you're using crutches, you don't have a place to carry your cell phone in your hand, your glasses, your MP3 player, your sunglasses, your keys, your drink, all of these things that you might normally have in your hands as you're walking around or getting out of your car. You can't put it in your hands because your hands are using the crutches and manipulating the crutches. So one of the challenges in the Invent It curriculum is to help invent a carrier, and that carrier can be for crutches or for a person using a wheelchair. So the first part of the challenge is to present it and to get youth engaged. How would you get them engaged in this challenge? How would you help them get excited about this idea? The handout that we have here is one that you can copy out of the guide, and it is designed to be something you could hand out to youth to help them see what the challenge is and get excited about it. But there's other strategies you could use as well. You could have the youth meet somebody who is using crutches or a wheelchair. You could give them an opportunity to experience it themselves, to bring in some crutches that are the right size for most of the youth in your program. You could have them try moving through your space in a wheelchair and recognize what the challenges are when you're moving yourself in a wheelchair. You can't use your hands to hold things because your hands are being used to turn the wheels of the chair. Have them think about what are the tasks that are challenging when they're using crutches or a wheelchair. Things like talking on the phone or carrying a drink can be very challenging, and maybe you can give them an opportunity to try those out as they're using those tools. What else could you do to make the challenge meaningful? You could make it a contest. You could introduce them to people who really need this solution. All of these things are great ways to help them get involved in this idea that this is a real problem that real people need a solution for. So imagine that you can get them engaged and they're moving forward on their creating a solution. How are they going to grow and develop as a result of this? They're going to develop critical thinking and problem solving as they go through this experience. They're going to have a chance to be creative, to develop empathy for other people, to help see themselves in someone else's position, and to imagine what resources or tools would make things easier for that person. A great way to build on this challenge and again to get people excited about it would be to take the prototypes that they developed to a nursing home or a rehabilitation hospital where they could have people actually who would use these solutions test them out. And again, learn from the experience of people who are dealing with these challenges every day about what's really useful for them and get some good feedback on their solutions. How much time would it take? Yeah, there's really a range of possibilities here. You could spend a day, a couple of days, or a week on this challenge. Or if you wanted to give them several cycles of designing and redesigning, maybe you could spend a month on a challenge like this. Have them brainstorm, create their first prototype, test it in the program. When they've tested it and they've got a solution that they've liked, then take it out and get feedback from potential users. Then come back and redesign and retest their ideas, so that it could be a month that you spend developing a convenient carrier over the course of many sessions, or it could be something you do in a couple of hours. So it's really going to be dependent on how you want to engage the youth in your program. The supplies that they're recommending for this activity are string, paper, cardboard, rubber bands, and duct tape. You could add other ideas too if you want to make it more elaborate. You could let them bring things from home. They might want to use boxes or other plastics to get a more durable solution. All of those things are potentials, and there are things that you need to think about if you're going to have an invention club like this. How much time do you want to spend on it? How much do you want to provide supplies? Do you want to open it up for youth to bring supplies into the club setting? All of these are important questions to answer, but the idea on all of these is we wanted you to have two different ideas about how you might approach this question of becoming an engineer. You can focus on your staff and using the resources like making it relevant, overview of learning, and the videos from Click to Science to help staff develop the skills in supporting youth in developing their identity, becoming an engineer. Or you can also think about it at the programming level. What are things that you could add to your programming so that youth have opportunities to explore this, like the idea of an inventors club as something you add to your after-school programming. Of course, you might need to do both at the same time. If you add an inventors club, are your staff going to need some new skills or strategies to make that successful? The big idea that I want you to take away from today's webinar is that engineering is for everyone in your program. Engineering is about solving problems, and all youth in your program have problem-solving skills, and of course they need to develop problem-solving skills. They're going to use these in their everyday life. So it is a benefit to all youth to provide them with these opportunities, and all youth have the potential to be inventors, to be engineers, and to solve problems like this. We are at the end of our hour, so I want to encourage you to take a moment to give us some feedback on today's webinar using the webinar evaluation form. I also want to tell you about what we have coming up for Click to Science. Our next webinar will be March 7th, and it's going to focus on leadership in after school. And registrations are also open now for the Click to Science National Trainer Institute, which will be in Omaha, Nebraska on May 22nd and 23rd. Early bird registration for the Trainer Institute ends March 8th, so register soon. at clickthesciencepd.org/trainer-institute. I'll add that link to the chat box for you. The Trainer Institute is really designed for people who are providing training to after-school staff so that they have an opportunity to develop their skills as a trainer. So I encourage you to think about whether there's somebody on your team that would benefit from this experience.